We present algorithmic results for the parallel, staged assembly of microscale objects from tiny particles. The underlying model has particles moving under the influence of uniform external forces until they hit an obstacle. Particles bond when forced together with a compatible particle. Previous work considers sequential composition of objects, resulting in construction time that is linear in the number of tiles. We prove that by successively combining subassemblies, we can achieve sublinear construction times for vast classes of shapes. For convex polyominoes, a constant construction time is possible. Our assembly process can construct any convex polyomino in 6 movement steps. Examples of how to handle bottom-side protrusions are shown here. Our construction process can be used for pipelining, resulting in an amortized, constant production time. In the hardware demonstration, we show how columns of the desired polyomino can be constructed in 4 moves. Particles are 0.5 mm neodymium cubes propelled by an external magnetic field. In the second example, we show how subassemblies can be constructed using force field moves provided by gravity. Here, the orientation of the global magnetic field keeps all polyominoes aligned.